Hi everyone. Today we are discussing about the strength of antigen antibody interaction. The antigen antibody interaction is a biomolecular association similar to an enzyme substrate interactions. These interactions are non-covalent interactions, include hydrogen bond, ionic bond, hydrophobic interactions and van der Waals interactions. These interactions are individually weak combined with a covalent bond. So, a large number of non-covalent interactions are required to form a strong antigen antibody interactions. Each of these non-covalent interactions operates over a very short distance of 1 into 10 raised to minus 7 millimeter. The strength of antigen antibody interactions can be determined by the terms of affinity and avidity. The first one is the affinity of the antibody. Affinity is the intensity of the attraction. It is a quantitative measure. The combined strength of non-covalent interactions between single antigen binding site on an antibody and a single epitope is the affinity. The low affinity antibodies bind antigen weakly and they can be easily dissociate, whereas high affinity antibodies bind antigen more tightly and they remain bond longer. The association of antigen and antibody can be described by the following equation. Here, the antigen binds with the antibody forms an antigen antibody complex. The reaction is reversible and K1 is the forward rate constant or association constant and K minus 1 is the reverse rate constant or dissociation constant. The rate of K1 by K minus 1 is the association constant Ka, a measure of affinity. Because the Ka is the equilibrium constant for the above reaction, it can be calculated from the ratio of the molecular concentration of bonded antigen antibody complex to the molecular concentration of unbonded antigen and antibody. The value of Ka varies for different antigen antibody complex and depends upon both K1, which is expressed in units of liters per mole per second, and K minus 1, which expressed in the units of 1 by second. For small haptens, the forward rate constant can be extremely high. In some cases, K1 can be high as 4 into 10 raised to 8 liter per mole per second. For larger protein antigen, however, K1 is smaller with values in the range of 10 raised to 5 liter per mole per second. The rate at which bonded antigen leaves an antibody binding site, that is the dissociation rate constant K minus 1, plays a major role in determining the affinity of for an antigen. Low affinity antigen antibody complexes have Ka values between 10 raised to 4 and 10 raised to 5 liter per mole, whereas high affinity complexes have Ka values as high as 10 raised to 11 liter per mole. The equilibrium constant for the reaction is the Kd, the reciprocal of Ka, that is 1 by Ka. Kd is the molecular concentration of unbonded antigen antibody to the molecular concentration of bonded antigen antibody. It is a quantitative indicator of stability of an antigen antibody complex. The stable complex have low values of Kd, whereas less stable ones have higher values. The affinity constants Ka can be determined by the equilibrium dialysis. This procedure uses a dialysis chamber containing two equal compartments separated by a semi-permeable membrane. The antibody is placed in one compartment and radioactively labeled ligand is placed in the other compartment. These ligands may be small enough to pass through the semi-permeable membrane. Suitable ligands include haptens, oligosaccharides, and oligopeptides. In the absence of antibodies, ligands added to the compartment B will equilibrate on both sides of the membrane. In the presence of antibody, the labeled ligand will be bonded to the antibody at equilibrium, trapping the ligands on the antibody in sides of the vessels, whereas the unbonded ligands will be equally distributed in both the compartments. Here, the graph plot of concentration of ligands in each compartment with the time. The total concentration of ligand will be greater in the compartment containing antibody. The difference in the concentration of ligands in the two compartments represent the concentration of ligand bonded to the antibody. The higher the affinity of the antibody, the more the ligand is bonded. The second one is the avidity. Avidity is the strength of bond. The affinity at one binding site does not always reflect the true strength of the antigen antibody interaction. When complex antigens containing multiple repeating antigenic determinants are mixed with antibodies containing multiple binding sites, the interaction of an antibody molecule with an antigen molecule at one site will increase the probability of reaction between those two molecules at a second site. The strength of such multiple interaction between a multivalent antibody and an antigen is called the avidity. The avidity of an antibody is better measure of its binding capacity within biological system. The high avidity can compensate the low affinity. One of the example, the pentameric IgM has low affinity than the IgG, but IgM has high avidity that result from the higher valence. So it enables it to bind antigen effectively. That's all about the strength of antigen antibody interaction. Thank you.